Hi, my name is Steve Myers, and this is part 4 of a paper that I presented in the Midwest SAS Users Group in Chicago in 2019. It's about exploring your data before you turn to analysis. We've done that in the parts 1, 2, and 3. In part 1, we talked about the need to not be hasty. And hasty work involves all of these different things that you see on the screen. And I invite you to go back to part 1 and look at that with a little bit more information. Part 2, we actually got to articulate the problem. The problem that we were presented is our female students paying higher rents and why. And we contemplated about this and used common sense and economic theory and came up with at least 5 variables that would be very important to explaining rent. Of course, the 6th variable is then female. And does over all those 5 points, does female stand up as a significant premium or difference in rents that are being paid? The problem is we have only the variables in red, and that's what we've been working on, a data set that we did not collect according to our design, but that doesn't make our design any less important. In fact, it informs us that there are variables that are in the errors of our structure that really we should take account of as we begin to anticipate what the actual results might be outside the data that we're actually using. We do a hasty regression. Now we're going to call this model 1. And it really is, we're going to take the 3 variables that we have, rent per person as our dependent variable, and rooms per person as an explanatory variable, and distance from campus. And this is really one of our primary variables, as it turns out, is that there's a real difference between males and females in distance. And then we say, given those two, holding those constants, does female make a difference? And our example here was, no, it does not. So in part 3, we went through and explored our data. But again, it's a small data set, and the idea of part 3 was to, with SAS, give you, the viewer, a chance to look at some opportunities to look at the data and make some decisions about the data generating process. We made a very simple decision that these 3 numbers circled were considered outliers in our data, and therefore we wanted to eliminate those from our analysis. Now we turn to a statistical look, not just an exploratory or descriptive look, but an actual statistical look at the differences between the 2 means. And we start off with a univariate test called a t-test, given in PROC t-test. And our class variable is sex, that is 0 if a male and 1 if a female. And our variable is rent per person. So we're really testing here the null hypothesis that the rent per person is not different by sex, and that we want to reject that hypothesis in favor of the alternative, in which case, according we can see the graphs here, the distributions, the alternative being that females actually do pay a premium. And it appears from our graph that females do pay quite a premium. Notice we're using the command where yes equals or clean equals yes. This is an indication that we defined in part 3 a variable called clean that has the value yes if it does not include any of the outliers or suspicious variables. When running a PROC t-test, the thing that you have to pay attention to the first is the last thing printed. And that is the block that we see here at the bottom, which is the equality of variances. As it turns out, you can consult any statistical text on this, that if the variances, the unknown population variance of rent per person for females is different than rent per person for males, then an adjustment has to be made. And this adjustment is called the Satterthwaite adjustment, and you can look this up in the SAS documentation and find a great deal of information on it. As it turns out, the equality of variances, given the p-value, the size of the f-value, the degrees of freedom, numerator and denominator, the f-value is not large. The p-value itself is large, and it says that we are going to, at conventional notions of significance, which we'd like to have, what, 5%, 10%? We have a 34% level of significance. We're going to reject the fact that fail to reject the fact that the variances are identical. So now we'll go up in the output from PROC T-TEST, and I'm showing you only a little bit here, and we will use the pooled method with variances assumed to be equal, and we end up with a t-value that is minus 2.94 and a probability that exceeds the absolute value of t of less than 0.01, which means we are significant at the 0.01 level. That's a very low p-value and does indicate that we have good evidence that the females are paying more. But remember, this is a univariate test. So now we want to take a look at that pairwise relationship between rent per person and the variables on the right-hand side. Rent per person is going to be our dependent variable in our analysis coming up, and rooms per person, DIST, and sex are our independent variables. And we see in the Pearson correlation coefficients for both the full and the clean sample that the correlation between rent per person and sex is significant. The p-values are very low, 0.0329 and 0.0066, and the coefficient, the relationship between sex and rent per person, seems to be quite high. In fact, on the clean data, it's even higher than on the full sample. But one of the things that we have to realize is that the confounding variables of distance and room per person may make a lot of difference. So we want to look not at zero order correlation, which is just a pairwise association, but we want to look at partial correlations, that is a pairwise association between rent per person and sex holding constant rooms per person and distance. And that coefficient falls from 0.49 in the bivariate case to 0.296 or 297 with a p-value that is generally too high to regard as significant. That is, that we would look at this relationship in partial terms and suspect that there is not a premium by sex once you hold the variables RMPP and DIST constant. So turning to some graphics, but nevertheless these are linear models, a linear regression and a loss regression, and we'll talk about both those in turn.